So here we go with the first lecture of the year. I'm going to do a little Algebra 2 review, a little simplifying rational expressions and complex fractions. So here's our first problem. Again, review from last year. What we're going to take a look at first is how to reduce this fraction. So as always, we look to factor the numerator out, and you can do this by guess and check. So I've got 5x for my first term, x for my second term. I got to get 1 by multiplying, so I've got two 1s. One's got to be positive, one's got to be negative. I need a positive 4x. So this term is going to be positive, this term is going to be negative. In the denominator, first thing you want to do always is look for a greatest common factor, and in this case you've got a 5, so I'm going to pull that out, leaving me with an x squared minus 2x minus 3. I'll continue to factor the denominator out. So when I do that, I end up with 5 times the quantity of an x here and an x there. Need a 3 and a 1 to get 3. And I need a negative 2, so that 3 better be negative, that 1 better be positive. And then, since we're talking about fractions, anything over itself reduces to 1. These terms reduce. This 5 and this 5 won't reduce because it's combined with a subtraction. So I'm left with the quantity of 5x minus 1 over the quantity of 5 times x minus 3. And it's okay to leave that fraction in that form. Our next problem is going to be a multiplication of two fractions. In general, we want to look to reduce, if possible, right off the bat. You may want to reduce this x cubed and this x cubed here, but we can't because of the subtraction in this case. You can only reduce exactly alike terms, and since that's separated by a subtraction, they aren't exactly alike. So we need to factor once again. It's going to be a common theme today. I pull out an x squared because that's GCF. I'm left with x minus 6. In the second term numerator, that's going to factor into a set of squares, so that's x minus 1 times x minus 1. Denominator of the second term goes to x plus 3 times x minus 1, and I have an x cubed as my last term. Once again, we want to find exactly alike terms in the numerator and denominator and reduce those. We can go vertically up and down or diagonally. So I see the x minus 1 is in common with the x minus 1. That goes. Now in this case, we have a factor of x squared here and x cubed here. There are basically two x's multiplied together here, three x's multiplied together there, which means I have an x squared in common in both, so I can reduce the entire x squared on top with the x squared in the denominator, leaving me with these two terms on top and an x plus 3 left in the denominator. And that reduces that fraction. Lastly, we're going to do a subtraction. And the first thing I want to do in any of these type of problems is factor my denominator. So I'll do that by pulling out an x, and I have an x plus y. And then I have difference of squares here, so that's x minus y and x plus y. And then the next step is to find a common denominator, which is the smallest term such that all my denominator factors will go into. So in this, I'm going to need an x. I'm going to need an x plus y. And I'm going to need an x minus y. So as you can see, the x goes into this denominator here, the x plus y goes into the denominator here, the x minus y goes into the denominator, and so does the x plus y. It's kind of repeated, but it only needs to go in one time. And what I like to do is rewrite my denominator twice, and then go about changing the numerators accordingly. So I notice that from this first term, I have an x and an x plus y. What's not represented is an x minus y. So to this first term, I'm going to have to multiply x minus y over x minus y, or by a form of 1. Thus, I'm going to have to take and FOIL. So I've got x squared plus 2xy minus xy minus 2y squared. In the second term, I notice I have an x plus y and an x minus y, but I'm missing an x. So I'm going to have to multiply by the form of 1, which is x over x. It's going to give me an xy minus 2x squared. Now you'll notice I have to subtract everything in this second term. So combining, I get x squared. I'll combine the 2xy and the negative xy to a positive xy minus 2y squared. And now I'm going to subtract each of these terms. So subtracting xy gets me a subtraction of xy, and subtracting a negative 2x squared gets me a positive 2x squared. And that's all over my LCD of x times x plus y times x minus y. Combining like terms, you see I have 3x squared. I have no xy terms because those reduce each other out. And then I have 2y squared over x times x plus y and x minus y. Now, if this numerator continued to factor, I'd want to factor that and try to reduce in the end, but in this case it doesn't, so I'm done. Alright, so that was simplifying rational expressions. Now we're going to take a look at complex fractions, which are basically fractions over fractions. We've got a couple of ways that we can take and solve these. For the most part, I like to find the common denominator of both the numerator and denominator to get this problem done. So I notice here that in the numerator, I have a 4 and an 8 as my two denominators, and in the denominator, I have a 1 and a 12 as my two denominators. The common denominator for both the numerator and denominator, in this case, the smallest would be 24. So what I'm going to do is I'm going to multiply both the numerator and denominator by the common denominator, or lowest common denominator of both the numerator and denominator. Distribute this in. Notice what happens. 24 and 4 reduced to 6, so I have 3 times 6. 24 and 8 reduced to 3, so that's minus 3, over 24 and 2 go to 48, and the 24 and the 12 reduced to a 2. So what now has happened is I've lost all my fractions, and I'm left with just one. So in this case, I have 18 minus 3, and that's going to be over 50. So I get 15 over 50. 5 goes into both, 3 times here, 10 times here, and I'm done. And we're going to use the same technique for all the other problems. Now we notice in this problem we've got some variable expressions, and we're going to have to find the common denominator of both the numerator. So in the numerator I have a 1 and a c squared, and in the denominator I have a c and a c squared. Common denominator of both, c squared. I'm going to multiply that to both terms in both the numerator and denominator. In the first term I have a 9c squared. Second term the c squareds reduce. In the denominator I have a c squared multiplying by 3 over c, so the c's will reduce, leaving me a 3c, and then the 2c squares reduce, leaving me with a 1. So now in this case you'll notice the numerator is factorable. It's a difference of two squares, so I have 3c minus 1 and 3c plus 1 all over 3c minus 1. So in this case I have the exact same term in the numerator and denominator, so these factors are going to reduce, leaving me with 3c plus 1. Next problem, very similar to the last, in that I have variables introduced into problems. However, now I have binomial expressions in the denominators, and notice these are completely different. So just like when we had numbers in the past like 3 and 7 in our denominator, 3 and 7, and our denominator would be 21, we just multiply the two together. We would do the same here. Since these denominators have nothing in common, I need to use both in order to establish an LCD. So in this case, we're going to take and multiply by a form of 1. And that form of 1 is going to consist of the two denominators combined. No need to multiply these out because they're going to reduce out anyways. And now I multiply each of these to the terms in the numerator and denominator. Here and here. So you'll notice in my first multiplication, the 3x plus 1 goes away. I'm left with 3x plus 5 times 1 minus 3x. In the second term, nothing goes away, so I'm left with 2 times 3x plus 1 multiplied by 1 minus 3x. In the denominator, nothing reduces in the first multiplication, so it's 3 times 3x plus 1 and 1 minus 3x. Added to, the 1 minus 3x goes, and I'm left with 3x times 3x plus 1. Now, the next step is kind of up to you. What I would do personally is I would look to factor anything in common. What you might come up with is, oh hey, just FOIL this out, combine like terms. That's an option. I think this option is a little bit quicker. You'll notice in this case that in the numerator, the 1 minus 3x term is in common in both, and in the denominator, the 3x plus 1 term is in common in both, so those are GCFs. I'm going to factor those out. I have a 1 minus 3x in common in the numerator, leaving me with 3x plus 5 minus 2 times 3x plus 1, which is a much easier multiplication to perform. In the denominator, I have a 3x plus 1 in common. And after factoring that out, I'm left with 3 times 1 minus 3x plus 3x. So now we just have to simplify the numerator and denominator and see what we have left. In moving through that, I have 1 minus 3x multiplied by 3x plus 5 minus 6x minus 2. That's all over 3x plus 1 multiplied by 3 minus 9x plus 3x. Again, let's simplify a little bit, and we end up with the following. We end up with 1 minus 3x times negative 3x plus 3, and then 3x plus 1 multiplied by negative 6x plus 3. This can be factored out a little bit more. I can pull a negative 3 out of this first term, giving me 1 minus 3x times x minus 1. And in the bottom, I can pull out a negative 3, leaving me with 3x plus 1 times 2x minus 1. And then we notice the negative 3's go, So our final answer is going to be 1 minus 3x times x minus 1 over 3x plus 1 times 2x minus 1. Another similar problem just for practice so you can see. Again, I have two binomials that are distinctly different in both the numerator and denominator. So I'm going to multiply by that form of 1 that contains both of them in my lowest common denominator for both the numerator and denominator. When I take and multiply that through, you'll notice again I have an x plus 2, x minus 2. My first multiplication, second multiplication, the x plus 2 goes, so I'm left with an x and an x minus 2. You're going to notice the similarities right off the bat. I have x squared times x plus 2. And in the second term, nothing reduces out, so I just have an x plus 2, x minus 2. I'm going to use the same idea as I did in the last problem. Find my common terms. I have an x minus 2 in common in the numerator and an x plus 2 in common in the denominator, so I'll pull those out as GCS. I also actually have an x in common in the numerator, so I'm going to pull out an x and an x minus 2, leaving me with an x plus 2 and a 1. In the denominator, you notice I have the x plus 2, so I'll pull that out, leaving me with x squared plus x minus 2. You'll notice in the numerator, I now have x times x minus 2 times x plus 3. In the denominator, you'll notice the second term factors, so I have an x plus 2 and I have an x plus 2 and an x minus 1. Notice nothing's going to reduce, so I just leave it as is, but at least I gave it a shot. So that's all we've got for today. What I'd like you to do is fill out the summary form right below this video, and then log on to my math lab and answer the couple of questions that I assigned for tomorrow. Thanks.